So in this lesson, I want to talk about how delta G and KEQ values relate to spontaneity. So first, I want to explain spontaneity, and it's basically the tendency of a reaction to kind of occur in nature by itself without the addition of free energy. So a spontaneous reaction, we can, an example of just dissolving some salt inside some water. We kind of just put the salt in, and it dissolves on its own in the water by itself. We don't really have to do anything. We can even write out the reaction as NaCl in aqueous solution dissolves to Na plus and Cl minus, and this just kind of happens on its own. And then a non-spontaneous reaction, we can give an example of lifting a dumbbell off the floor, right? This doesn't just happen by itself. Dumbbells don't just levitate in the gym off the floor. We have to input energy from our muscles, right, to lift this dumbbell off the floor. And so going back to delta G right here, this value, what does this mean? This is essentially the change in free energy. A positive delta G value means energy is kind of absorbed into the system and inputted. And a negative delta G means energy is released. So if you go right here, we said a positive delta G is when energy is put into the system, which is characteristic of what? Exactly. A non-spontaneous reaction, right? So delta G is positive in a non-spontaneous reaction because we put energy in to the system, right? We put energy in to move this dumbbell up. And conversely, this means delta G will be negative in a spontaneous reaction because energy is actually released in this process. When the NaCl is dissolved in the water, energy is released, which makes this spontaneous. And so now we have these two things that are very important. Delta G is negative and spontaneous and positive and non-spontaneous. And now we can transition over to KEQ. So what is KEQ? KEQ is essentially the concentration of the products over the reactants. So we have products on top and reactants on the bottom when the reaction has come to equilibrium. So when the concentrations of the reaction products are unchanging and the reaction is essentially done, for lack of a better term. And we could kind of use this reaction that we had over here, this NaCl dissolved to NaCl, as to demonstrate this. So the Na and the Cl minus are the products, while the NaCl at the bottom is the reactant. So we said that this is a spontaneous reaction, which means that at equilibrium there will be a lot of the dissolved NaCl because it just happens on its own, right, without the addition of free energy. So this top number will be really large, while this bottom number, there won't be a lot of it. It'll be really, really tiny. And since the top number in the fraction is large and the bottom number is tiny, that means KEQ will be really large, so large that it will be greater than 1 in a spontaneous reaction. And so we could also examine the inverse relationship in a non-spontaneous reaction, where for a reaction, right, we have KEQ equal products over reactants. We said that a non-spontaneous reaction is unlikely to happen in normal conditions. So that means there will not be a lot of products. This top number will be really small, and this bottom number will be really, really large. So in the fraction, we have a small numerator and a large denominator, which means KEQ will still be positive, but it will not be greater than 1. It will be in between 0 and 1. And so now we have these four things where we have, for a spontaneous reaction, delta G is negative, and then KEQ is greater than 1. And then for a non-spontaneous reaction, we have delta G is positive, and KEQ is between 0 and 1. And I hope that helps.